Okay, so I've made the adjustments to the amplifier that I planned out yesterday, and you can see now that when I increase the throttle, we do actually get a very nice signal that's pulsing between 0 and 5 volts. And as I increase the speed of the motors, it decreases the period. And since it's only going up to about 1.5 kilohertz, it's well within the range of the switching speed anyway. Although I did have to make some concessions with this, so the entire purpose of me having this Schmitt trigger to provide the positive and negative power rails was so that I wouldn't have to deal with these filtering or these DC opposite capacitors. So then I would be able to get the exact position of the poles of the motor. But now, it would, if I had some 2.5 volt Zener diodes, I could place them parallel with the capacitors on the output to clamp the voltage to 2.5 volts. Now the problem I'm having right now is that the positive and negative power rails aren't precisely matched. So there's always a tiny offset by a few millivolts, plus minus 0. Sorry, a few millivolts around 0. Which means if I don't have these capacitors to remove the DC offset, as the gain on the amplifier increases, it just amplifies the offset, so then I can't get a signal out. So what I've done right now is I've just put the capacitors there to filter out the DC offset, which does completely nullify the entire purpose of having this negative power rail, but it's working for now, and I don't have the parts to solve the problem in the way I just mentioned. So I'm going to stick with this and see how this goes. But yeah, since we actually do get a variable signal now, I'm not going to bother to have a Schmitt trigger on the end to clean the signal. Because originally I was expecting it to be a sinusoidal shape, but basically what I've done is that I've set the gain of the op amp so high that the op amp is being saturated by the Hall effect sensor. So that's why it's clipping at the top, giving us a square wave. I think I'm just going to leave it like that, because that means I'm not going to have to add the comparator or the Schmitt trigger at the end. And that'll simplify the process quite a bit, and I can be done with this part and go back to looking on the camera. Right, so I've just started testing the second Hall effect sensor, and it works fine on its own again. But there's a problem when you try and connect both Hall effect sensors to the negative voltage rail, and it's that even though these sensors draw maybe a few milliamps at most, even a few milliamps is too much for these logic devices. So I had to think of a way to get around the fact that one of these packages had such low power output. And all I can really say is that AMD isn't the only company that knows how to do 3D die stacking.